I'm going to show you how to do homology modeling right now. That's a way of obtaining a model structure of a protein that you've got the sequence information for but hasn't been crystallized. And you're going to base it upon the structure of a protein that has been solved. And essentially what you do is you loop the linear sequence of your protein onto the three-dimensional backbone of the known structure, and then do some energy optimization. You don't actually do that, the program does it for you, so it's basically just a matter of cutting and pasting. And so we'll start at the Expasia website, as we've done before, and go on the right hand side. You'll see a link to Swiss Model, and that's what we select. That's the modeling site. And on the left hand side, there's various things you can do here. We're going to be in automated mode. The example we're going to use today is cytochrome B5, and we're going to use as our template structure, that's the known structure, bovine cytochrome B5. And so down at the bottom where it says PDB ID, we put in its protein database accession number and also the chain that we're going to use. Now the protein that we're going to model this to is going to be the goat protein. Now I've already looked up the accession number, so I'm just going to paste it in this part here. You could also just paste in the actual linear sequence. The program can actually handle that. Sometimes this program takes a long time to run, so rather than wait around for it to finish, you may want to have it emailed to you. So you would put your email address in and then the project title. So in this case I would say goat to cow B5, just to remind myself. Sometimes this can happen very, very quickly, but you know, the Trent internet connection is sometimes slow, and sometimes there's slowness at the other end at the SwissProt site. So this is one of those cases where you just want to go and get a coffee or something while the alignment program is going. Once you do this, you just hit the submit modeling request, and then you wait. In this particular case, it's not going to take that long, but in the interest of actually keeping this tutorial short, I've already done this alignment before. There's a bunch of information here. For example, this part here tells you how good your model is, or how good your model is expected to be compared to the actual structure. And so for example here in this particular one, it's colored so that where it's blue, we're expecting fairly good agreement between the model structure and the true structure. What we really want though is a structure that we can view within PyMol. So this will generate the model structure as a PDB file. So we click on this, we can download the model structure. And once we've got that, we can view it in PyMol, and we can also overlay it, for example, with the original template to see how good those two structures are to each other. Basically, you'll be doing the same thing in the Tuesday lecture. I'm going to talk a bit about bioinformatics, but there will be plenty of time for you to do this model building and model retrieval. And it's quite likely that when we do the assignment that you're given, that is due at the end of the month, it will incorporate a little bit of this as well too. So we'll see how that goes. It should be pretty interesting.